Hello everyone. This is our video in the series of O-level videos. This video is on circle theorem, and we will be covering many videos. We even previously have videos on circle theorem, but this is updated, built more strategically, and based on some of the new concepts and some of the concepts which basically come together with circle theorems, right? So let's straight away dive into the topic. Right. So before starting the topic of circle theorem, we need to understand all the nitty-gritties of a circle, right? We need to know what each part actually means. So this right over here, this is your chord, okay? And this is your chord. This, which only touches the circumference of the circle once and then moves away. Sorry, that is your tangent, right? This is a minor segment, right? This is your circumference. And this whole line, which is passing from the center of the circle and touches both the parts of the circumference, that is your diameter. The half of the diameter is your radius. This is your sector, right? And this would come up as a minor arc, right? That would be, the other one would be a major arc, and this is a minor arc. So these are all the parts of the circle. Before we move forward, I would like to tell you that Pengrow is having its exclusive math O-level classes for the preparation of October, November 2023 and May, June 2024. And you can enroll in these classes. We are having early bird discounts right now, and you would not want to miss them. All right, let's move further. So circle theorems, right? They are laws related to angles and lengths. And before diving into these laws, we need to see some non-circle theorem laws because they are going to come into handy once we start the circle theorem laws, right? So these are not circle theorems, but this is something you should know, right? And you already know this, that angles in a quadrilateral, they add up to 360 degrees. So if this is 90, this is 90, this is 50, this would be 130, right? And the base angles of an isosceles triangle, they're basically equal, right? So this angle and this angle, they're equal, right? For an isosceles triangle, right? Let's move further, right? Now we are going to start with some of the circle theorems. Now you need to understand the first circle theorem says that the angle which is formed between the radius and the tangent. We've already seen the tangent. Tangent only touches the circumference once and then moves away. And the place where the radius touches the circumference, that forms a 90-degree angle. So the angle between the radius and the tangent, that is 90, right? And then angle in the semicircle is 90 degree. What is the meaning of this? That when you have from the diameter, the two lines are coming and they meet at one point in the circumference. So it's basically covering half of the circle, that is the semicircle, right? So the line is the whole diameter. It is meeting at one point on the circumference. At that point, there will be a 90 degree. Now, these are written. Angle between radius and tangent is 90 degrees. Angle in semicircle is 90 degrees. You should remember these wordings because in your exam, you're supposed to write them. Okay. So always remember in this case, in this example, your diameter will always be the hypotenuse because it will be the length which is opposite to the 90-degree angle. Right? Let's move further. So here we are done with two theorems. Let's look at other theorems. Okay. Angles in the same segment, they're equal. What do I mean by the same segment? See, we discussed previously that since both of these are coming from the same 2 points, this is forming a segment. This is a segment, right? And these are being formed in the same segment. So this angle is equal to this angle. An angle at a center, this is your center and this is your point of circumference, right? Angle at the center is twice angle at the circumference. Here the word is being cut. So angle at the center is twice the angle at circumference, right? So I hope these two theorems are also clear to you. You can revisit them to actually learn them, right? We also have, we can also give access to you of our free notes, and for that you can contact us through our email or our phone number, okay? Or you can WhatsApp us on. Now, we will look at the next property, which is the property of cyclic quadrilateral. Now, the first thing, why are we calling it a cyclic quadrilateral? The reason being that it is not only a quadrilateral, it is a special kind of quadrilateral because all the points of this quadrilateral, they should touch the circumference. Only then it would be a cyclic quadrilateral. And opposite angles of a cyclic quadrilateral, they add up to 180 degrees. So if one of the angle is x, the other one would be 180 minus x. A normal quadrilateral only has the property, what property? That all the angles add up to 360 degrees. But a cyclic quadrilateral, in a cyclic quadrilateral, the opposite angles add up to 180, right? Okay. The lengths of the tangents from a point to the circle, they are equal, right? These tangents, they are equal from the point to the circle. So basically, what does this mean? That from this point to this point, let's label this A, let's label this B, let's label this C. So what we are trying to tell you here is that AB equal to BC, right? Okay. Then another important, this is not basically a theorem, these are just small tips I'm trying to give you because these are the simple things which students tend to forget in their exams. When you have multiple radiuses, right? All the radiuses are equal, so just put a mark on them so that signifies to you that all of the lengths of all the radiuses are equal. And many a times, one kind of question has appeared in the exam when an isosceles triangle is formed in the circle, and that is possible because of both the radiuses being equal. So they don't even need to write. They don't even need to make these lines. This should be obvious to you. This should be coming to you. Now we have done all the properties. Now let's look at a few questions. We're not properly looking at questions in this video because this video had the purpose of actually giving the concepts to you. So just to make your concepts proper, we're going to look at a few things, but after this, we're going to move forward. Okay, so let's look at this. Identify which circle theorems you could use to solve each question. So this is the first question. We need to find this value of angle O, and we know this angle is 100. You can see that a cyclic quadrilateral is being formed here, right? Let's reveal the properties for now, and then, once we move to the questions next time, we won't be revealing the properties. So here in this case, once we have opposite angles of the cyclic quadrilateral, they are equal. For some reason, these words are not coming, but no issues. We are going to solve the question. We are going to walk through it, right? Opposite angles of cyclic quadrilateral, sorry, they're not equal. They add up to 180 degrees. So this is going to be 80, right? And when this is going to be 80, now we need to find this. So angle at center is twice the angle at the circumference, right? So this is going to be twice. 80 into 2, this is going to be 160. So we get our answer of 160 for this, right? And yes, we're correct. Now let's look at this. This is quite simple. We have, okay, Let's reveal the property first. It's only one property, angle in same segment are equal. We can see the same segment here, right? Your segment. And if this is 70, this would also be 70, right? Yes. Okay. Here we have the tangents concept and let's reveal. So angles of quadrilateral, this is not a cyclic quadrilateral, it's not being formed. If you see this, four sides, it's just a simple quadrilateral. And angle between tangent and radius is 90. So we already know this angle very easily. This one. This is a 90. This is also a 90. And we know it adds up to 365. So 90 plus 90 is 180. And then 180 minus 65 would give us the answer, right? Let's check the answer. That is 115. 180 plus 65. 180 minus 65 is 115, right? So yeah, we are clear on this concept. Looking at this concept, identify which circle theorem would you use to solve each question. Again, base angles of isosceles triangle, you need to remember where can I actually see the radius? This is my radius and this is my radius. They're equal. So this is going to be 20, right? Okay, because the base angles are equal and angle in a semicircle. That is 90. This would be 70, right? And this is also radius. This is also radius. So this would also be 70. Okay. So here our answer would be 70. Right? Let's try another question and this is going to be our last question. So let's reveal the properties. Here we have 116. They're telling us that these two lengths are equal. Okay, right, we understand. Here you should realize this is the same segment for this angle. So this angle is going to be equal to this angle. Now, you need to know this angle to actually know this angle. Now, this is an isosceles angle. So you can simply find the value of this. So that, how would you know? 180 minus 116 divided by 2, right? So 180 minus 116 would be 64 and 64 divided by 2 would be 32, right? So this would be 32. And if this is 32, so this is also 32 because angles in the same segment, they're equal, right? Yes. So with this, we end our video. I hope you gain some knowledge and we're going to post the next video in this series and you can let us, you can let us know which topic you want by commenting and I might leave you with a small question. This question you should try on your own and we are going to discuss this question in the next YouTube video and please post your answers in the comment, right? Till then, I'm going to see you later. Bye.